Okay, so back here in our capture point, we have our server logic. Now we need to run something that runs on everything. Basically, grab that widget component that we made. Now this is the widget component. So we actually need to get the widget itself, which can be confusing if you didn't, think about that. So get widget. Give me the component for it. All right, and then what we need to do is we need to cast into the class that we just made. So what is it? Capture point world widget. And that setter that we made. All right. And just like previously, we set a reference to ourselves. So now the widget will know about us, and we'll add this into the first sequence. That way it runs on all clients. And sometimes your server is a player as well, because, well, it's definitely going to be in our case because we're not doing a dedicated server. So one of the players is always the server in this case. All right, you could add a comment there saying exactly what that does, which is add a reference to the capture point in the world widget. Okay, moving on. So I'm just going to straighten these up just a little bit. Got a little messy here. Okay, so we made our progress timer tick. Let's go ahead and add a comment already. And then move it out of the way. We don't forget about it. Got that timer running. Set it down here. But we need to handle the actual overlap events. So let's get that work out of the way. So if you select your collision sphere right here, drag this window out over here. We're going to use overlaps. So on component begin overlap, like that. Move it up over here. Do this again. We got the begin overlap. We also want the end overlap. This is for our collision sphere. Okay, overlaps will trigger both on the client and server, I believe. So let's steal our authority check from up here. And let's do that for both. So this is going to occur when a character overlaps with them. And then what we need to do is over other actors, so not this actor, but the other actor that's overlapping, drag off over here. It says handle actor detected in collision sphere. Remember, that was the function that we made to spoof that we were overlapping. And then we're going to add the was added check. And then over here, though, copy paste that. We're going to remove that, connect up your actor. Okay, and then organize that. Just say like begin overlap end. All right. Okay, and so then that's, since we made this is a great part about functions. You don't have to worry about doing any massive copy paste or whatever. All that logic's just going to run that we have. Nothing more needs to be done. So let's move on. Okay. Wow, I can't spell. Timer. Okay. Progress timer tick. Once again, this is only going to happen on the server. The reason we run so much stuff on the server is because if it's game deterministic, has no business running on the client. You should almost never send anything from the client to the server that determines whether the game is going to be won or lost. So all this stuff must be done on the server if it determines points or things like that. So let's make a function called update team progress. Just so we can keep the logic that we run here, nice and clean. We don't need this big old thing. And then somebody can just look and be like, okay, this is all that happens. All right, no big deal. And then they can just surgically go in there and do what they need to do to that one function. Okay, this one I'm going to say is optional. You don't need to do this. You could put an authority check here or not. I think the only place we're going to call this is going to be from that one we already have an authority check. But we are Blueprint, and technically anybody could call this function anywhere. So it doesn't hurt to have another check there. That might be a little redundant for our specific case, but you never know. The guy you're working with might not be the best. It happens. So anyway, moving on. Let's get our catch game state. Let's right click to it, convert it to a validated get. Okay, so we really only want to continue to tick if the game is still scoring. So we really need to make a check to know if the game is still scoring. And we wouldn't put that logic here in our capture point. We would put that in our game state. So let's go to our game state. We have a function here. Let's make a new one called, let's see, maybe is game scoring. And we haven't made the scoring timer yet. So what we're going to have to do is just make the timer handle. So let's see, score. Okay, and that's going to be a timer handle. We'll eventually set this timer. But, so just to kind of clarify, the capture points have their own ticks going on, and the game itself has its own tick, the master timer. That's what we're checking here to see, hey, is the game even doing any scoring yet? Or is it scoring at all? Because it's not going to score between rounds. Is timer active by handle? And we're going to make a return. So to make a return on a function, you click this, push output, here like this. And just type in active. Or you could even say, you know what, I would just like it was, yeah, that's fine. Press Q to clear that up. Okay, so is game scoring? So we got that done. Go back to our capture point. Come off of here. Is game scoring? Okay. So so let's talk about a couple things. Let's go back into that function. Highlight it here. Okay, a few things we could do here. Drop down to the advanced. Since we're not changing anything, we can make it const. Why is that important? Well, what that does is it makes it so you can't do anything that changes anything. Since it's just a question, it's not changing anything, we can make it const. Now, in C++ code, it's a little more clear that we're const because it's not a hidden checkbox, and it indicates, hey, nothing is changing anything here. We're just asking questions, things of that nature. So we can mark things const. The other thing we can do, and what that does is anybody who looks at this knows nothing is changing. So that helps. Another helps is our the way we formed the function name. Anything like that's bool in nature should be like a question. That's why I said is game scoring. Now the Blueprint specific thing we can do also here is click what's called the pure button. And what does the pure button do? That means that anytime this function is called, it reruns the whole function rather than saving off the variable as it would if it wasn't pure. So it can cost performance actually to make things pure if you're not careful. But since we're only using it in one spot, it's not going to cause a problem. So as you can see, the whole look of it changed. That's because I made it pure. And see, we're only using it here in one spot, but if I had further spots down the road, every time a pure function is referenced, it's going to rerun the logic. This is good if you were doing like a random number generator and you wanted a random number every time. You wouldn't have to keep calling the function. Well, you make it pure, it'll do stuff like that. But it does look a lot neater and more organized, so that's why a lot of people, I'll see them using pure functions. What you never, ever, ever want to do is hook one of these bad boys up to like a for loop. Don't do that. You'll cause bad problems, especially if you have some complicated logic in there that's not just a bool. Okay. So let's go ahead and embark on one of our more complicated functions. So what we need to do at this point is, if the game is scoring, we need to determine the scoring team. So let's make a function that does that. Okay, and because we're just determining the scoring team, as we mentioned earlier, we could make this const, but let's not make it pure, because we're going to be running some logic in here, and I don't want it to be running that logic over and over and over again. So let's start by making a sequence node, just to keep ourselves organized. Okay, and if you remember, we had that characters and collision sphere array. Let's drag that out. Let's get it, and let's loop through it. Okay, as said before, make sure when you're running off anything that's an object, which is an actual thing in the world, it's not just data. We need to do an isValid check. Usually anything light blue, it's a good sign. You need to do an isValid check for it. Now, run a little bool branch over here. So what do we want to know about this specific character? Well, we want to make sure he's still alive. So to do that, we're going to pull off of here, and we're going to see, is his player health. Okay, we don't have that yet. So let's create player health. Now, where do you suppose we should put that? Go back over here. We'll put it in our character. The reason I don't put it in a place like the player state is, I don't want player state persists whether the pawn is there or not, the actual character. The player state, think of it like the soul, and the character is like the body. That soul, whether the character dies or whatever, is still existing. So if the player's health goes down to 0 and you try to assign that player state to another pawn, guess what? His health's going to be 0. So realistically, it would make sense to have it on the thing that actually dies, so that way when its health goes to, when he gets, respawned or whatever, it's back to its default state. And that's what happens when you make something new. It's back to its default state. So it makes sense to have the player health on the actual character and not on something like the player state. Well, let's add player health. Okay. Let's see here. Let's make that a float. And let's a couple more things. Let's set that to 100. I know that this is going to be replicated. So let's go ahead and do that and have a little discussion about it. For replication, we want to do rep notify. So what's a rep notify? Well, when that value gets changed, it's going to call a function. This is very handy, so you know, because there's a delay, right? When the server sends information to the client, and that's what replication does. When set on the server, not on the client, when the data is set on the server, it will send that data to the client. And if that value changes, and only if that value changes, it will call this on rep player health function that was just created when I made that a rep notify. Okay. Now there's caveats with this function, and it behaves differently in native code than it does in Blueprint. And I'm going to try to get this right. So no matter what, the onRep function that I just double clicked will always get called when you set the value on the server. On the client, it only gets called if the value changes. It's like a performance sort of thing. In native C++ code, it only gets called on the server if you explicitly call it, and it will only get called on the client if those values change. So there's a little difference there. You're going to have to play with it. This causes a lot of bugs. Why they're not consistent, I don't know. We're going to deal with some other unique array issues that are a result of this. So one piece at a time, though. Let's just work with this player health. So let's drag it out here. So basically, when this function is called, that means the value has updated on all the clients. And so we want to tell everybody about this change, anything listening to it. So rather than do something that's not performant, like check if the player health has changed over and over and over again, we're going to make this event that fires off whenever the health has changed. Yes, it's fired here, but we need to make something that people can do what's called subscribe to. And people, I mean widgets, I mean anything could say, hey, I'm really interested in whenever the player's health has changed. So we're going to make something that they can listen to, and that's called an event dispatcher. In C++ code, it's called a delegate. In fact, they'll call it a multicast delegate that has nothing to do with a multicast RPC. We'll get into that some other time. But that's what it is in native code. But we're not there. We're just calling them event dispatchers. So we're going to call this one on player health changed. Then we're going to drag it out. And we're going to call it. And what we want, and these things do have bugs in code, by the way. Okay, so I was clicking on here, and I want to add that variable in there, and I was like, why can't I see my details? Just make sure you have this clicked on. It's little stuff like that will throw you for a loop. So we're going to add an input. We're going to say, let's say player health, in player health. Just like that. Make it a float. And sure, somebody could look at the event and know that what we're talking about is player health, but it's pretty handy to have it come flowing through there. So anybody that subscribes will say, we'll get an event. They'll have their own function in their own class that'll get called off. And so we don't have to reference over here all the time. And then the player health will come out, and let's say it's a widget that subscribes to this. It'll be like, aha, the player health has changed, and I need to update. That's way better than having the widget say, hey, has player health changed? Has player health changed? Has player health changed? It can just listen to it. This combination for on reps, this right here where you have the on rep combined with the event dispatcher, that's like the number. That is used so much for replication that this strategy right here, you need to really ingrain that in your head and take it with you wherever you go, because it's the most common way for servers to communicate with clients in an efficient manner.